Hello, everyone. My name is Rob Higurita, and I'm a Principal Technical Account Manager at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower cost, and provide you with best practices and design considerations. And joining me today, we have Mike and Sukhmeet from AWS Enterprise Support. Can you give us a quick introduction quickly, Mike, and then Sukhmeet?
Hey, I'm Mike Wells, a Senior Technical Account Manager from Boulder, Colorado, and I enjoy supporting customers' operations and cost optimization efforts in the cloud. And today I'm going to dig in on security groups and how to find out what's using them. Sukhmeet?
Thanks, Rob and Mike. Appreciate it. Everyone tuning in, I'm Sukhmeet Mara, Senior Technical Account Manager based out of the US East. I come from a machine learning and AI background, and I've been helping our customers to develop highly scalable ML solutions like computer vision, gene processing, market forecast, etc. As a TAM, I get to put my technical skills and coding skills to use by helping our customers in building, managing, and deploying solutions on AWS, as well as helping customers in their modernization and digitalization journey. Today, I'll be answering questions from repos regarding compute, specifically talking about how to install packages on Amazon Linux machines. Rob, back to you.
Great. Thank you both for the introduction. And so, as they both alluded to, we're going to be answering some questions. And of course, you can hopefully probably see the answering your repost questions on compute. But before we get into all the details, a quick note to everyone watching online. Please feel free to use the chat window on the right-hand side of your screen to let us know where you're joining us from today, and also to ask questions throughout today's episode. We really do look forward to hearing from you all and getting some interaction. So please feel free to take advantage of that chat box over there. I'm also going to be dropping a link to a survey. So if you'd like to let us know how we did today, please click on the link and leave us your feedback and let us know what else you'd like to see. So these are the three questions that we're going to be answering today on the show from our AWS repo site. So Mike's going to tackle tracking what is using your security group, which is a pretty common question for our users to figure out when they want to clean stuff up. Sukhmeet's going to be covering installing packages on Amazon Linux 2 instances, another common item asked. And then I'm going to be following that up last with how to do an allowed list on IP addresses in security group in a few different fashions. So first off, though, I'm going to kick it over to Mike to get us started answering our first question from Repost.
Hey, today I'm going to be talking about what's using different security groups inside of your AWS infrastructure. And this is a common question because folks want to know whenever they're updating their security groups, how this is going to impact anything. So first thing I want to cover is what a security group is. And a security group acts as like a virtual firewall for your EC2 instances to control incoming and outgoing traffic. And inbound rules control the incoming traffic to your instance, and outbound rules control the outgoing traffic from your instance. And when you launch an instance, you can specify one or many security groups. And if you don't specify a security group, Amazon EC2 uses the default security group. And you can add rules to each of those security groups that allow traffic to or from its associated instances. And you can modify the rules for a security group at any time. So what happens is folks set up security groups and then they attach those to different things. And then they have these big pile of security groups that they don't know what goes with what, or whenever they change port 80 to be allowed on this particular security group, they don't know if that's going to allow it for any particular set of instances that they might have. So what I'm going to talk about today is how to find what's using those security groups. To see what's using one of your security groups, what we need to do first is understand that the security groups are attached to a network interface. And a network interface is just a device or card or virtual thing that connects an instance or some resource in AWS into the internet. So what we'll do is in the EC2 console, on the left-hand side, there is a menu, and network interfaces is one of the things that we can select there. So what we'll do is copy our security group here and then paste that into a search for network interfaces, and then we can see the list of network interfaces that this is attached to. Once we find the network interface that it's attached to, we can click on that network interface and then see the actual instances that are attached to this security group. In this screen, there is a instance ID on here to be able to see what instance is using this. If you're like me, I prefer to do things in the command line. It's a lot easier to be able to programmatically do things and to do things over and over. So at AWS, we have a command called describe network interfaces that allows you to be able to send in a search string to be able to see what network interfaces are attached to a certain security group. So I'll just run this one real quick. And what I did was put in the security group in this terminal and the region, and then that shows me the interfaces that this security group is attached to. This particular one only has one attachment, as you can see here, but if it had multiple attachments, then it would list each one of these out in the screen. Thank you very much. And I see that we have a couple of questions in the chat here. Do you know of a way we can find out in AWS if traffic is being blocked to a certain instance due to security groups blocking it? And I'm just looking at this now.
Hey, Mike. Yeah, so we have a couple questions that came in while you were going through. The first one actually came in from Landcarl22. It's important, a thing that we didn't cover initially. Landcarl said he's a new attendee here and new to AWS offerings. Can you share what Repost is and what it's used for? So I do want to cover that really quickly here, and then we can get to the second question too as well. But if you're not familiar with AWS Repost, it is the new AWS forums for going out and being able to ask your questions. And it's got some additional features to it that the AWS forums didn't have previously. So when you ask a question, we do actually have AWS experts like myself and Mike and Sukhmeet being able to go out to those questions and answer them. We have some kind of process also as well wrapped around it to notify, like I subscribe to the areas that I'm an expert in to be able to answer questions and also review other people's questions to make sure that they're accurately providing answers and insights to users. So if you haven't visited Repost before, definitely go take a look at it. We've also got some new features where we have community-based articles as well that are launched there that are helpful for community members that are experts in areas to be able to write little community articles as well to share insights and info, which you'll probably see each one of these 3 questions that we're talking about today shared as community articles later on. So if you go check Repost in the future, you'll be able to see that. So thanks for the question. Second one though, Mike, was the one you mentioned there. Do we know a way we can find out if AWS traffic was being blocked to a certain instance due to security groups blocking it? The primary thing there, and I don't know, Mike, if you want to answer this as well, but I'm happy to take it if you want me to.
Sure, I'll add some color after you interrupt, Rob.
Okay. You can, but only if you had, say, VPC flow logs enabled to go back and look at those logs. Post-mortem, if you didn't have VPC flow logs, you're not going to have a record, essentially, of what traffic was being sent where and blocked by what. So it would be a little hard to tell unless you had VPC flow logs enabled. And if you do, then you can go through and look at your VPC flow logs to be able to see, essentially in what line of the metadata about your traffic the block was happening. Was it inbound to the security group or coming back out? So you could see if it was the NACL or a security group that was, kind of blocking it. Mike, do you have anything else to add?
Yeah, just flow logs can help you with a number of tasks like diagnosing overly restrictive security group rules, as you mentioned, monitoring the traffic that's reaching your instance, and determining the direction of the traffic to and from the network interfaces. Yeah, thanks a lot for the question.
Great. All right. I think we're handing it over to Sukhmeet now. So.
Thanks, Rob and Mike. That was a great start. So up next, what I'll be covering is a lot of our customers are, and we've been getting a lot of questions on Repost about, what do I do if my EC2 instance running Amazon Linux 2 doesn't have access to the internet? Meaning, what happens if my EC2 instance is behind a private subnet or doesn't have access to the internet or doesn't have a public IP address to it, right? This is a common question and it can be easily handled. What I intend to show here is, a brief description about what needs to be done and how we get to a resolution to this, right? Most important thing to know here is Amazon Linux repositories are hosted in Amazon S3 buckets, right? To update packages without an internet connection, you have to do 3 things. Create an S3 Amazon VPC gateway endpoint, include a policy that allows access to the repository's buckets, and then associate the VPC endpoint with the routing table of the instance subnet. That's really important. You can access Amazon S3 from your VPC using gateway VPC endpoints. And after you create the gateway endpoint, you can add it as a target in your route table for the traffic, destined from your VPC to Amazon S3, right? Another question that we get on a similar note is, how do I access third-party repositories such as EPEL? EPEL is extra packages for enterprise Linux. You need one out of four of the following. You need at least a NAT gateway, a NAT instance, internet gateway, or a VPN direct connection to your data center that routes the YUM request, which is the package manager, the YUM request through the public internet. So it's really important to know all these points before we head to a resolution. A few more important things to know. The EC2 Instance security group must allow outbound HTTP traffic. The S3 VPC endpoint security group must allow inbound HTTP traffic from the EC2 instances subnet. And then the NACLs associated with the EC2 instance subnet must allow the following, meaning, there should be, you should allow egress on port 80 and 443, which is HTTPS and HTTP and HTTPS follows. And then, ingress on ephemeral TCP ports from the regional S3 service. These are really important points. And then we look at the runbook. Everything that I said up top, is put together in 7 or 8 different points or steps that you need to follow. All right. We've looked at the important steps. We'll look at how to navigate through the steps that I was talking before, which is setting up the S3 VPC endpoint. First off, head off to the Amazon EC2 console and find out the instances that are running or the instance that's behind the private subnet. Go to the networking tab, note down the VPC ID and the subnet ID, and then we will search VPC console up top in the search bar. The idea is for us to look at the route table and find the route table ID. So for that, we'll go to the subnet that we just noted. We'll select the subnet, go to the route table, and then select the route table ID or note down the route table ID. Once you have that, you have all the information that's needed to create the endpoint. Next up, we'll click on the endpoints, create endpoint up top. We'll just give a random name to the endpoint. In this case, I'm doing test S3 update packages, right? And then we are looking for a certain service. There's 3 sets of information that we need here. The service that we're creating the endpoint to, so that is com.amazonaws.useast1.s3. Feel free to change the region, meaning where your EC2 instance is hosted, and then select gateway type. And then select the VPC ID that we noted up top and the route table. Select full policy and click on create endpoint. Voila, your VPC endpoint is done. All you have to do now is go back to your EC2 instance and then update packages, or you should now have the ability to update the packages as well as YUM. So I'll take a pause here to see if we have any questions here.
Hey, Sukhmeet, thanks. No questions from the audience about patching right now from the Linux box or installing and getting access to those. So appreciate your sharing some insights and information on this as well for how they can get access to those repositories from those private subnets, which is a pretty common thing for our end users to be setting up. So,
right, thanks.
Yeah, great. I will take it over from here to answer our third question on how we're going to allow list IP addresses into a security group. There's a couple different ways that you're going to be able to do this. So I'm going to cover 3 of those different methods that we can use. Some of them covering from on-premise to AWS, some just within AWS, and then a little bit on a common use case for this for a little easier management for you as users. So our question that came in from Repost is we're trying to give URL access to some specific users as their application is hosted on Elastic Beanstalk. And since the URL is public, they would like to make it private. So in this instance, they've decided to use Elastic Beanstalk to host their website, right? But they would like to make sure that only users that are supposed to have access to this. which is pretty common. If you don't have access to something like Direct Connect or a VPN to only expose, the private IP addresses to this, you may have to, change your inbound security list for those security groups to limit this. And so what we're going to cover is 3 different ways that you can accomplish the same thing, just depending on where your traffic is coming from. And so our first one's going to cover using users at an office site. And really, this is also applicable to those coming from the public internet. They just might have their public IP ranges that you're going to allow list into your security group rather than these private IP addresses that we're going to be talking about today. In this instance, we've got our users that are coming from our 10.10.0.0/24 IP address space at our office site, say one of our offices in a regional location. So we're going to basically have a VPN that we have connected into our AWS environment that's going to give us our connectivity. But if we want to say only specific users on this 10.10.0.0/24 can get access to our Elastic Beanstalk, we could still limit that and say only the 10.10.1.0 users would be able to have access or not. And we're going to do this simply by adding in this range of IP addresses. And you can do multiple ranges of IP addresses and have a long list of IP addresses that are allowed access to port 80, say to get access, or port 443 to get access to your secure website. This is going to be one way that you can allow if you have, say, just one site that you're going to be allowing, or say you just have one IP address that you're going to allow in. Pretty simple, quick, easy way for you to say, only this IP address is going to have access to my Elastic Beanstalk environment and therefore be able to access my website. Now, if you have security groups that you have set up and you've got EC2 instances in AWS and you're trying to do the same thing, but it's actually users from within your AWS environment, instead of, say, allowing the 172 or the 10./24 or /16 whole VPC CIDR range into your Elastic Beanstalk, you could instead just use a security group ID from the users that are going to be accessing your Elastic Beanstalk environment. And that way, say if you've got a virtual desktop implementation of users that are accessing your Elastic Beanstalk, and those IPs might change, as long as they are users that are in this VDI environment that has a security group assigned to it, you can just say, allow that security group into this Elastic Beanstalk environment security group, and it's going to grant you access then to be able to access that website on the ports that you have running there. So it's going to be another quick and easy way for you to allow and not have to constantly go back and say, okay, well, I got to change this IP address because that user's virtual desktop, IP changed for some reason. Maybe they got a new one or they had an issue with one and had to swap it out. And of course, we want to make sure that there's ease of administration of things that you're doing, so that you don't have to spend a lot of people power going in and constantly changing IP addresses and such. So a few different ways there. Last one I'm going to talk about is a little bit more of a scalable method for you to be able to allow in IP addresses to your environment. And it's used in a couple different ways. For this instance, we're going to talk about very similar setup where we had users at a remote site. We've got our VPN connection into our AWS, but now we've got multiple sites. So say your company's grown, you've got 3 sites, future you're going to have 5, 10, 15, 25, whatever amount of sites. And each one of those has a unique IP range that you're going to have coming into your environment. Well, as I mentioned in the first way, we can just add a single entry and say, hey, allow 10.10.0.0/24 to have access to port 80 and port 443. And then do the same thing for 192.168.10, and then do the same thing for 172.10. And we'd have, 3 individual lines. Well, if you can imagine, as you continue to add more and more sites, you're going to have to continue to go in that security group and remember to add more and more items to that. So this could be a little bit cumbersome, could create a number of entries within your security group, and might just be a little bit less clean for you to be able to go back and track. If you're like me, I've done this before where I've added in different IPs and such into my security groups, and it becomes a very long list. And for you to go through and audit that list takes time. It's a little bit more error prone for you to be able to go in and look at that. So we have an offering within AWS that can have customer managed IP prefix lists. And these IP prefix lists are going to be a prefix list that you design. That's PL and then dash whatever the unique identifier given to it. But then within that prefix list, you can assign a number of different IP addresses. And you have one location where you can go through and easily and quickly see, give a description to those IP address spaces that you're allowing into the security group, and be able to define it that way. There's also some additional items there that you can do within there. So like I said, give it a description. We do have other prefix lists that are Amazon managed ones, but I will show those as we get into the console here and show you just a quick, easy way that we can get these 3 different options set up to allow list you into your environment. So I'm going to switch over to a quick demo here just to walk you through how we can do each one of these different items. So just pull that up here. So we're just going to be into our EC2 console because that's where all of our security group items are going to be located. And then we'll jump over into the VPC where our managed prefix lists are. But if you're not familiar with AWS and EC2, right, all the security groups can either be accessed here or through the VPC console, either or. And I have a few different security groups that are set up for different things. And one of them is going to be this OpenVPN security group that I have set up. And I have this one set up for exactly like I showed in these slides, where I have remote sites that I'm going to have connected through this OpenVPN solution from all those sites into my AWS environment. And I want to control who has access to what. This OpenVPN security group is going to be assigned to my Elastic Beanstalk environment or whatever environment in AWS to allow access to my resources. So you define inbound and outbound rules in your security group. We can see in this one, I don't have any current inbound rules because it's a new security group. So I'm going to add some different rules to address the different ways that we were talking about. So I'm going to say, give it to HTTP access. And I'm going to have my IP range that I'm going to put in here that I mentioned before, that 10.10 IP space. And that's going to grant the users from that location to my resources here within AWS. And it's going to be a nice and simple way for me to do that when I just have one site to do so. So as we can see here by this rule, I have the type is HTTP. It's going to open up TCP port 80 to my custom range, which is this 10.10.0.0/24. And if we wanted to, I could give a description for this. I'm not for this purpose of this demo, but I like to put them in my real rules just so I remember what it is, because if you're like me, might be a little forgetful later on the road what that IP range actually belongs to, and the description field is just kind of a nice way for you to be able to remember why you put that there. So I mentioned before we could do a security group access, so we can instead do the same thing where we give HTTP, have TCP 80 that's allowed, specify custom, and now I can do SG-, and that's going to give me a list of all the security groups that I can use to allow access. And so I have one that's web server access. So I'm going to say, hey, all the EC2 instances that get put into this web server access security group that use this are going to have access into this environment. So it's another easy way for me to grant a group of users without having to go in and add individual IPs and administer it that fashion to grant access to that. The last way, as I mentioned in the slides, is going to be using a prefix list. And we will have to switch over to the VPC console here in order to look at the prefix lists. But as we can see here, I've got my 2 rules defined. And now, say I've added 2-3 more sites to my environment, and I'm like, I really don't want to have an individual line per site. I would like to go to a more scalable method that I can actually then also share with my organization if I create this prefix list of my remote sites. All right, so we come into the VPC console. We see we have a whole bunch of different options over here in the VPC console now compared to what we had in the EC2 from our different transit gateway options, mirroring sessions, security ACLs. But we're going to focus today specifically on this managed prefix list option because that's what we're going to be creating our own customer-defined managed prefix list that we're going to use for our custom deployment. We can see I have 4 different prefix lists that are here already. All of these prefix lists are Amazon managed ones that I can use. So say you've got a CloudFront implementation that you're using and you have an application load balancer that's going to be kind of where you're sending traffic to as well. Say you have a security group on there and you want to say, I only want to allow all the IPs from CloudFront to have access to this, where we could use the prefix list that's defined for CloudFront and grant access that way, instead of having to go through and manually look up the IP addresses in the CloudFront for the IPs JSON and create our own prefix list. We can use some of the Amazon managed ones to help us with that. For today, though, since we're talking about our custom sites that are going to be our own remote sites, we're going to create our own custom prefix list here and do it for our remote sites. So we'll just come in and give it a name for this prefix list, and I'm just going to name it remote sites, nice and easy. It's going to be for IPv4 addresses. And when we have to define a max number of entries, so we can see here I'm putting in 10, just factoring in some potential growth. I only have 3 today, but give me a little bit of wiggle room. This can be changed later on. So once you have a prefix list created, you can go back in and modify this to change it after the fact. So no big deal if you set it low and then in a year you realize you've got 30 sites that you need to add that are brand new, you can go by and modify this. So we're going to add different entries, and we're going to add CIDR blocks that match our remote sites that we had previously of our 10.10, our 172, and our 192, 168 to give us access to our resources, but in a nice centralized managed location using this prefix list instead of adding in it. So I have my 10.10, my 172 here. We're going to add in our 192, 168. And as you can see, these have description fields too. So if I wanted to label these like my Chicago location, my Dallas location, my Detroit location, my San Francisco location, I can go ahead and add in descriptions as well. Highly recommended in the future so you actually remember this, what each one of them is. We can add tags, but I'm just going to create my list here for today. And I'll see that I get a PL-unique identifier. That's my remote sites prefix list. So now that I have this prefix list with those IP addresses that are going to be defined for my remote sites, I can now add in one line to my security group instead of 3 different lines. I can create different associations for it, right? As I mentioned before, I can share this. So if I have 100 different IP addresses in this list in the future, and I don't want to have to recreate this in every single account that I have in my organization because they're all going to use this remote sites list, I can just share this list with them and they'll be able to have access to it as well. So nice and easy for you to be able to make other people in your organization's life easy, hopefully, as well with their administration of things. So let's pop back over to my security group. And we're just going to edit that security group again and be able to add in this prefix list that we have instead of this 10.10.IP address of 192 and a 172. We'll just come in and we'll say, I'm going to add a new rule for this. And like I said, I've still got these other ones, but I'm just going to do PL dash, and it's going to give me a list of all my different ones. We saw remote sites, so I choose that. And now I've got a entry for my IP, my security group, and my prefix list. Well, I don't need this 10.10.0.0/24 any longer because I've already gone ahead and included that in the prefix list. And so you want to reduce the duplication of things that you have in your security group and those rules. So we'll be able to go ahead and quickly and easily remove this 10.10.0.0/24. And that's going to allow us to just use the prefix list instead for everything. So that's all I've got for a demo right now. So I'm going to bring Mike and Sukhmeet back in here and try and answer some of these questions that we got while I was chatting away about leveraging the different methods for granting access to AWS resources. So I saw we had a question that came in from Tommy242. Welcome back. Tommy242 wants to know what's the difference between Elastic Beanstalk and EC2. So Sukhmeet, did you want to take that one?
Yeah, I'll take that one. So Amazon EC2 is a web service that provides secure, resizable compute capacity in the cloud, right? Virtually allowing you to deploy any kind of workload. That's Amazon EC2. That's number one. AWS Elastic Beanstalk is an easy-to-use service for deploying and scaling web apps and services. You could use Java, .NET, Python, so on and so forth, or even a Docker container to deploy that, right? So you simply upload your code, and Elastic Beanstalk automatically handles the deployment, capacity provisioning, load balancing, auto scaling, as well as health monitoring, right? So those are the primary differences. But important thing to know here is Elastic Beanstalk it gives you an abstraction layer, right? It will set up an environment for you, get the EC2 instances set up in your account, maybe an optional database if you want that, a few other components like, again, security groups, auto scaling groups. And then Elastic Beanstalk will manage these for you whenever you want to update your software or code, right? So you get the CI/CD built in, right? So that's the most important thing to know. I hope that answers your question. Rob, Mike, feel free to add your color in.
I think you hit on everything there that I would say for it. So makes it nice and easy to be able to do multiple deployment methods and such. And that's kind of one of the nice features to using it. So
Yeah, A/B
great.
testing as well. You could have
Yeah.
multiple environments, rolling deployment. All of
Yep.
that is possible easily.
Yep. Very much so. So great. I just had another question that came in from MonRamon357, and welcome back to the show, MonRamon. How does a site-to-site VPN work with Amazon VPC? And so I'm happy to answer that one. So a site-to-site VPN is going to be something that you're going to deploy from your location to AWS. And there's a number of different, we call customer gateways or CGWs that are supported to connect to what we call a VGW or a transit gateway, a TGW, in AWS. And so what you're going to do with these, right, is depending on your deployment and your usage and scale, you may have your site-to-site VPN that's going to go from your location to your AWS VPC via a VGW or virtual gateway here in AWS. And that's going to allow you to just basically tunnel private traffic. It does go over the internet, of course, but it's still basically an encrypted tunnel between your location to your AWS environment that you can then use those private IP addresses to route traffic through rather than having to have things exposed to the internet, say, in your AWS environment. I mentioned the transit gateway in there because it's a little bit more of a scalable mechanism for you to attach to multiple VPCs with the transit gateway. TGW also supports things like equal cost multipathing, so that you can actually take advantage of, say, our VPN limits a 1.25 gigabit per second limit on a single VPN tunnel, but you can use ECMP to, say, do 3 or 4 different tunnels and expand the bandwidth capabilities to a transit gateway. So a little bit higher throughput, more scalable due to the direct attachment. But that's a little bit about how you're going to be able to use a site-to-site VPN with your Amazon VPC. Okay. Well, I didn't see any other questions that came into the chat yet. So I appreciate Mike and Sukhmeet, all of your sharing, answering of the questions that we had. So everyone, today, we took a look at answering some questions from AWS Repost. As we mentioned before, if you haven't checked out Repost, head on over, because if there are any questions that we didn't get a chance to answer today, or you think of something right after we get off air here, please feel free to head over to repost.aws, where one of our experts can provide you with an answer on your question, and it could become a topic for one of our future shows. So if you have feedback for us, please check the chat box on the right-hand side for a link to our survey that I posted earlier, or you can feel free to email us at awssupportsyou@amazon.com, because we really do want to hear from you and let us know what you would like to see on the show and how we did today. So thank you, everyone, for joining us at AWS Supports You, and happy cloud computing.